Hi everyone. I'm going to do a few examples from the homework, which is from exercise 11D, and we're going to apply the double angle formulas for sine 2 theta and cosine 2 theta. In class, we will derive these formulas, but this video is going to show how to apply them. So let's go ahead and go over a few examples. Number one, given sine theta equals 3/5 and cosine theta equals -4/5, find tan of 2 theta. So we know that tan of 2 theta is equal to sine of 2 theta over cosine 2 theta. So we're going to have to find the numerator and the denominator. So let's go ahead and use our formulas. So sine of 2 theta equals 2 sine theta cosine theta. So I'm just going to go ahead and substitute for sine theta. We're given 3/5. For cosine theta, we're given -4/5. And if you multiply and simplify, you get -24 over 25. Now cosine 2 theta, you have three different equivalent expressions you can use, but I'll go ahead and just use the first one. So we have cosine square theta minus sine square theta. Cosine square theta means that we're going to square cosine theta, which is -4/5. And then we're going to square sine theta, which is 3/5. And then if you simplify, you get 16/25 minus 9 over 25. And that's equal to 7 over 25. Oops, here we go. And then the last step is to find tan 2 theta. So I'm going to go ahead and put sine of 2 theta, which was -24 over 25. Cosine 2 theta, which was 7 over 25. So I'll go ahead and divide fractions by multiplying by the reciprocal, and I get -24 over 27. Let's look at the second example problem. If sine theta is equal to 5/13 and theta is in between pi over 2 radians and pi radians, find the exact value of sine 2 theta. So we're going to use the double angle formula, and we know that sine of 2 theta equals 2 sine theta times cosine theta. So we need to find cosine theta. We're going to use the trig identity. Sine square theta plus cosine square theta is equal to 1. And that is a Pythagorean theorem using the legs of a right triangle. So let's go ahead and substitute in for sine square theta. We'll have 5/13 squared plus cosine square theta equals 1. So this is equal to 25 over 169 plus cosine square theta equals 1. So cosine square theta equals 1 minus 25 over 169, and that will equal 144 over 169. So now let's go ahead and take the square root of both sides, and we get cosine theta is equal to plus or minus the square root of 144 is 12, and the square root of 169 is 13. Now we're given that theta is in between pi over 2 and pi, so that means it is in quadrant 2 right here. Okay. So that means that cosine theta, which is the x-coordinate, is negative. So that means we want the negative value. So what I want to do is write down quadrant 2, and so it's going to be -12 over 13. So now what we're going to do is substitute in to the double angle formula. So we have sine of 2 theta equals 2 sine theta cosine theta. 2 sine theta was equal to 5/13. Cosine theta was negative 12 over 13. And if we multiply through, we get negative 120 over 169. All right, for the third example, we have if theta is acute and cosine 2 theta equals 3/4, find cosine theta and sine theta. So we're given cosine 2 theta, so we have to decide which of the double angle formulas would make sense here. And in this case, the one that has cosine 2 theta and cosine theta by itself with constants would be the one we would use. So I'm going to go ahead and write down cosine 2 theta equals 2 cosine squared theta minus 1. Okay, so in this case, we're given cosine 2 theta and we want to find cosine theta. So this is a formula that would make sense to use. So cosine 2 theta here is 3/4, and we're going to just solve this equation. All right, so we have 2, I'm going to bring this over to the left side, equals, this would be 1 plus 3/4 or 7/4, and then divide by 2 or multiply by 1/2, and I get 7 over 8. I'm going to go ahead and take the square root of both sides, and I get cosine theta equals. Now, the information given says that theta is acute, which means it's in quadrant 1. So therefore, we know that it's either positive or negative square root of 7/8. But because we're in quadrant 1, cosine theta here is positive. And so therefore, we're in quadrant 1. Okay, you have to give the reason why you pick the root that you do, either the positive or the negative. So this is going to be a positive 7/8. Okay, which is our cosine theta. Okay, so now part B, we want to find sine theta. So how do we find sine theta if we're given cosine theta? Well, we can use our Pythagorean theorem where we have sine squared theta plus cosine squared theta equals 1. So I'm going to go ahead and substitute in cosine squared theta. Square root of 7/8 squared equals 1. And then we just start simplifying. Look, this is a plus. Isolate sine squared theta. Take the square roots. And we have sine of theta equals square root of 1/8, positive or negative. Now again, it's in quadrant 1, so therefore it has to be 1 over square root of 8. Okay? Okay, for our last example, we're going to use the appropriate double angle formulas to simplify. And simplify simply means, for example, if you had, say, a fraction 4/8, okay, when you simplify it, you get an equivalent expression, but the numbers are smaller, but they have the same value. So in this case, we're going to simplify, so we're going to make it equal to an equivalent expression, but basically it'll take up less space, or it just looks cleaner. So here are our formulas, and if you take a look at letter A, 2 sine squared theta minus 1, I see that this one looks very similar to this one, but the numbers are in reverse in a subtraction problem, which means that this is actually the opposite of this. Okay, and why is that? Well, let's think about it over here. If I have 7 minus 3, which is equal to 4, then I know that 3 minus 7, if I switch them, this is 4, this is negative 4, but if you take the opposite of a negative number, you get a positive. Okay, so that's basically all we're doing here, is we are switching the two numbers that we're subtracting, but then we got to take the opposite, and that makes it equal to the expression on the left. And I know that 1 minus sine squared theta is equal to cosine 2 theta. And that would be a more simple expression. Okay, letter B, we've got 3 sine theta cosine theta. That looks very similar to 2 sine theta cosine theta, but I have to change the 3 to a 2. So how do I go about doing that? Okay, well, let's go ahead and put a 2 sine theta cosine theta, but then we have to make this number multiplied by another number equal to 3. So I can go ahead and multiply it by 3/2, because if I multiply it by 3/2, the 2's cancel and you get a 3 left over. So these two things are equivalent. And then I'm going to further simplify. I'll leave the 3/2, but I know 2 sine theta cosine theta is equal to sine of 2 theta. So I'm going to go ahead and put sine of 2 theta. Okay. All right, letter C, we have 2 sine of 2a cosine of 2a. Again, this looks very similar to this one right here, but in this case, theta is equal to 2a. So what is going to happen? Well, we're going to take the 2 sine theta cosine theta. This is kind of like my theta here. And I'm going to take the theta and multiply by 2, so I'm going to have to take the 2a and multiply by 2. So this is going to be sine. Now what is 2a times 2? Well, that's going to be equal to sine of 4a. Okay, which is the same as 2 theta. So theta is equal to 2a. 2 theta is equal to 4a. And then the last one, we have 4 cosine square beta minus 2. And again, this is just a Greek letter we're using as a variable for angles. And so this one looks very similar to the one down here, if you guys can see that. This one at the very bottom. And yeah, let me fold this so you guys can see it a little better. Okay, so the only thing is, instead of a 2 and then a 2 here, which is actually 1, we have a 4 instead of a 2 instead of a 1, and then a 2 instead of a 1. So what it looks like we could do is we can go ahead and factor. So what does this expression have in common? Well, let's take a 2 out. So divide this term by 2, and we get 2 cosine squared 2 beta. You're not going to divide the 2 beta by 2. You just divide this entire thing by 2. Okay? And then the 4 and the 2, they simplify to 2. And then here we have minus 1. Now, what we're going to do is, again, we're going to take a look at the 2, and we'll ignore that. But then we have 2 cosine squared theta minus 1. So in this case, the 2 beta is our theta. Okay? And this is going to be equal to cosine 2 theta. But in this case, our theta is 2 beta. So we multiply 2 beta times 2, and we get 4 beta. So I'm going to leave 2 on the outside. And then this is going to be cosine. Normally, it would be, let's see here. cosine of 2 theta, but in this case, our theta is equal to 2 beta. So I'm going to multiply 2 beta times 2, and I get 4 beta. Okay? And then we're done. Okay. So practice these. These types of problems take a lot of practice to kind of recognize the pattern and to be comfortable figuring out which double angle formula to use. But just, do the best you can, have faith in yourself, and if you have any questions, go ahead and email me or post them on Edmodo. All right.